Bill Nye the Science Guy. Bill Nye the Science Guy. Bill. Hmm? I'm talking to you. Talking to myself. Bill Nye the Science Guy. Okay, Module B. We've come to that point now, and only 3 chapters for Module B, so we'll go through these quickly. For Chapter 7 specifically, I have a few problems just because there's a lot of, especially these upcoming modules, there's going to be a lot more conceptual and then like really, think for yourself type of problems beyond just like, oh, numbers itself. You want to say, oh, what are we working with? So we want to make sure we go through anything possible that can be seen in assignments, exams, and whatnot. So let's get right into it. For Chapter 7, I'm going to do number 1. Let's read that out loud real quick. How many capsules, each containing a 150 microgram dose of a drug, may be prepared from 0.12 grams of the drug? And Chapter 7 is more about dosing calculations. So just a heads up for that, you guys. So we worked with a problem like this before, actually, in last chapter. We have a total amount of a drug that's being used, and we wanted to divide it into capsules, each dose being this amount. I think that was chapter 1, actually. So pretty simple. You just want to make sure that you're noticing the units, grams here, micrograms here, micro, not milligram. So let's work it out. Let's start with making the units equal first, right? So 0.12 grams. Just working it out for you guys. Times, we'll put gram here at the bottom. So how many micrograms are in 1 gram? So gram is the standard unit, then there's milligrams, and then there's micrograms. So 1,000 times 1,000, 10 to the minus 6. So that's a million. There's a million micrograms per gram. Think of it as just like you have a big ball and small ball. You need a bunch of those small balls to equal the same size as that one big ball, right? So I'm not gonna zero those out. I'll use my calculator. Times 1, 2, 3, 4, 5, 6. 120,000. Probably could have figured that out. Micrograms. All right. So that's how much total drug. That's how much total drug we have in micrograms. Now we want to divide that, and we want to find out how many capsules we'll get from a certain amount of dose, which is 150 micrograms. Divide by 150 micrograms per dose. If you want to be really technical and write it out, that's fine. So dividing this number with a division in itself. So dividing by another number that's also being divided, right, unit-wise, so that microgram per dose, when you're dividing that, it flips. And then these are 2 different ways of writing microgram, by the way. So now we calculate that. 1,000 divided by 150. 800. And let's just say capsules. We probably should have said capsules instead of doses, but I hope I'm not confusing anyone that way. This should be capsules. 150 micrograms per capsule. Pretty simple, simple division. Yeah, that's number one. Let's go ahead to our next problem. Again, just being aware of units before really get into numbers, right? A physician reduces a patient's once daily dose of conjugated estrogen, brand name Premarin, from tablets containing 0.625 milligrams to tablets containing 0.45 milligrams. So the patient was originally on 0.625, and we're decreasing it now to 0.45. Question is asking, what is the total reduction in conjugated estrogens taken in milligrams during a 30-day month? So not only are they asking us what is the reduced dose, it's the reduced dose for a month. That might be, yep. So let's just get it right into that, right? So first we need to, what are we looking for first? We need to find out what the reduced dose is. How much are we reducing this drug by, right? In terms of strength-wise. So don't think too hard. That's just simple subtraction. 0.625 minus 0.45 equals, let's type that out, 0.625 minus 0.45, 0.175. That's in what milligrams? Okay, so that's per day. So it's a once daily dose, and so that means you're just taking one tablet per day of this Premarin, and each tablet or dose in this case is 0.175 milligrams. So this can be twice daily dose. Then we need to multiply whatever we get from the subtraction times 2 times a 30-day dose. So we really need to make sure we're reading that. Luckily, this is just a once daily dose. So now this is per dose, basically per day, because this is once a daily dose. We want to know how many milligrams it will be for 30 days. And since each day is one tablet, we'll just multiply it by 30, right? So 0.175 times 30. Whoops. Whoops. 5.25 milligrams for 30-day supply. Pharmacies, you might see DS per day supply. You learned something else besides math today. So that's the answer for number 2, 5.25 milligrams. Is that correct? Yes, it is. Okay. Okay, number 3 was a homework problem, and that the numbers in that problem were edited by the professors themselves. So let's just go that way. Let's read it out first. It looks a little long, but we can work it out. A patient cuts 240 milligram scored tablets to take his 120 milligram prescribed daily dose. A prescription for 3,240 milligram tablets costs $45, and a prescription for 3,120 milligram tablets costs $40. The patient asked the pharmacist to weigh an uncut tablet on an electronic balance into 2 halves. The uncut tablet was found to weigh 240 milligrams, and the cut halves weigh 125 milligrams and 115 milligrams, respectively. Question A, how much money did the patient save on a monthly basis by dosing with half tablets? B, what was the percentage error in the weight of the cut tablets compared with exact halves? So you have a big question like this, there's a lot of information. You want to try to understand what information is going to be relevant for what question. So A is asking how much money did the patient save on a monthly basis by dosing with half tablets? So this is probably going to be relevant, $45, the $40, and its respective strength and day supply, right? So for 3,240 milligram tablets, that's going to cost them $45. And then for 120 milligram tablets, it's going to cost the patient $40. So that there's money and there's numbers of tablets. That's, if you really think, that's kind of what we need for this problem. And then what was the percentage error in the weight of the cut tablets? We weighed the tablets in the second half of the question, and we're getting two uneven numbers from 240, divided from 240 milligrams. So that might be what we need for percent error. And we remember the percent error is error divided by the desired amount. Error being the actual amount minus desired. Yeah. All right. So let's just go in. Let's start with A and work that out. Okay. So the patient is cutting 200. Think of it this way. Like that's what I was talking about, thinking beyond the numbers themselves, right? So we know that the patient is splitting his 240 milligram tablets because his dose is actually 120 milligrams. That's how much he's supposed to be taking. So we know that logically, we should think that, hey, it's going to take him less amount of tablets to satisfy 30 days. So let's just say he gets 30 pills. If he's splitting each pill, technically he only needs 15 pills to satisfy a 30-day supply. So how we should go about this is we should find out how much each pill costs first of the 240 milligrams. Then we can find out based on how much 15 pills might cost, and then compare that to a 30-day supply dose of 120 milligrams. Because if it's 120 milligrams, that's the desired dose. He's going to have to take one of each pill, and he's not dividing that compared to the 240. But the 240, he's breaking that in half, and so he's going to need less pills to satisfy 30 days. So let's write it out, may seem a little clearer that way. So $45 for 30 tablets of the 240. So we need to find out how much each tablet costs. And then, so like when we explain it to ourselves, that's kind of how you might see the units at the end. We want to find out what the cost is per tablet. Cost per tablet. That's probably the dollar per tablet. So that's how we set up our units. $45 divided by 30 tablets. And this is to find out how much it's going to cost per tablet, right? So, I mean, just by numbers, you could plug it into the calculator. It's going to be 1.5. All right. 1.5. So $1.50 per tablet. So that's how much we know it's going to be per tablet. Now we need to know how much it's going to cost for 15 tablets. Why do we say 15? Because we're splitting now these tablets, and that's going to satisfy the 30-day supply. Now that we have one for half a tablet per day. So 150 per tablet times 15 days. What are you doing here? Oh, let me fix that for you guys. $22.5 for 15 days. Okay, so that's for 240 milligrams. Now we want to compare that to a full supply of 120 milligrams. That's 30 days each, and that costs $40, right? So we don't have to calculate anything because we already know that's how much that cost is given to us. So for 30 days, 120 milligrams, it's $40. So obviously we're seeing that it is cheaper to just split the pills of 240 compared to maintaining a 30-day supply of 120 milligrams. They want to know how much they're saving based off of that. So you can go either way, but 40 minus 22.5, that's going to be 17.5, $1750 saved. So it wasn't so bad. You just have to think beyond the numbers themselves. What is this patient doing in this scenario? If he's splitting them, then that means that and such. So that's for A. Let's go ahead with B. What was the percent error in the weight of the cut tablets compared with exact halves? So like I said earlier, we want to make sure, like with a big paragraph like that, you want to find what's relevant first to that each respective question. And so there's weight and there's percent error. That kind of applies to that second half right there. So remember what the equation for percent error was. It's error. So let's do it for each tablet and just see how it goes, right? So what we actually have is 125, and our desired is 120 over our desired 120. $125 minus 120 divided by 120. And then that's our answer, but we want a percent, right? So we multiply it by 100. Our answer is 4.1, let's say 4.17%. Okay. I'm going to show it to you guys by numbers, but just like so you can also see from 120 milligrams, it's 5 off in this number and 5 off by that number. So if you think of it that way, it's technically going to be the same answer, but we'll show it anyways, right? 115 minus 120 divided by 120. Now, sure, you're going to expect a negative number, but just for the purpose of percent error, you want to keep it as a positive number, 4.17%. So it's the same thing. And okay, so that's number 3. How long did you have lab for? How long do you have left for? I can edit it later. That's fine. I'm playing. It's still recording. All right, so we're gonna move on to number 4. Also another homework problem. So we have a formula, or an Rx in that case, for aralgin, an otic solution. And it consists of antipyrine, 54 milligrams, and then 14 milligrams of benzocaine, and then 1 milliliter of glycerin, dehydrated as directed. So that's kind of going to be the quantity of the solution itself. And so they give us this background of the dropper and what. Let's read that out. If a dropper delivers 20 drops per ml, how many milligrams of benzocaine will be delivered by a 3-drop dose of the solution? Okay, so sounds messy, right? There's mLs, there's drops, there's milligrams. But let's go at it one at a time. We're thinking of dosing. So you want to, so they say a dropper delivers 20 drops per ml. So we should first find out how many drops it's going to take to create this solution, or will the solution consist of, basically. So we can do 20 drops. So it shows 20 drops per ml. 20, I'm going to abbreviate it right here. One less letter. Times the solution consists of 1 ml. So that's 20 drops. So it's going to take 20 drops to make this solution, basically. And they're asking how many milligrams of benzocaine would be delivered by a 3-drop dose of the solution. So when they're asking for a quantity for a multiple or something, you should first try to find out what amount it would take per single unit of that dose. So and then once you have that unit dose, you can multiply by whatever multiple you need to reach that whatever answer they're asking for. So in this case, we need to find the unit dose of the unit amount of benzocaine per drop, and then be able to multiply by 3 to get your answer. So let's do that. So we know there's 20 drops total, and we want to find out how many milligrams per drop. Remember what I talked about, how when you're reading your question, it kind of basically gives your units. How much drug per drop, milligrams per drop. Pretty cool, right? So 14, they're asking for benzocaine, so that's 14 milligrams. 14 milligrams divided by, and that's 14 milligrams in the total 20 drop solution. We're trying to find out how much of the drug is in each drop. 14 divided by 20, if you want to do it by your head, divide these by 2, that's 7 over 10, that's 0.7. 0.7 milligram per drop. Okay, so now we have our unit amount. Now it's per drop, sorry. 0.7 milligram per drop. Now we need to find out how much benzocaine is in 3 drops. Just multiply by 3 drops times 3 drops. If you want to think dimensionally, this cancels out with this, and you're left with the amount of the drug. 0.7 times 3, just to show you guys, 0.7 times 3, 2.1. So it's not more about showing you guys how to do it itself. It's more about how you extract more information and where do you start. So you have to think, when you're thinking, oh, this is asking for doses, we need to find something to divide by and then find our unit reading off the question. And that's how we get our answer. Okay. Then I have number 8. That is our last question for chapter 7. Let's erase this off real quick. All right, moving on to number 8. Let's read it out real quick. Ciprofloxacin oral suspension contains 250 milligrams of ciprofloxacin per 5 ml. So that's what the suspension each bottle contains, right? A physician prescribed 125 milligrams of ciprofloxacin QID. So that's 4 times a day, QID. QD is 1 times a day, or daily basically. QID is 4 times a day, times 10 days. First question is how many doses are needed? Second question, how many milliliters should be given per dose? And third question, how many milliliters of ciprofloxacin oral suspension containing 250 milligrams per 5 ml should be dispensed? Okay, so let's start with how many doses are needed. So it's how many doses are needed is basically just saying how many times is a person going to be taking this according to the prescription. So we don't worry exactly about strength and whatnot for this question. We're just looking at how many times this person is taking that. So we look at the SIG. Just assume for a prescription, that's the SIG, right? Person is taking an amount of ciprofloxacin 4 times per day. Write that out. 4 times a day. 4 times per day. And then for what is the regimen? How long is that person taking this prescription for? 10 days. 10 DS. Like I said, it's 10-day supply. So days cancel out. 4 times 10 is 40. 40 times or 40 doses total. That's our answer for A. Okay, dosage would include the amount of drug as well, but based off how many times this person is taking. Dose itself is just how many times the person is taking it for this regimen. So next question, how many milliliters should be given per dose? Okay, so they're asking for 125 milligrams of ciprofloxacin. So I'm going to write it out first to you guys and then just like, you know, just kind of show to you guys what we can do without math, right? So what we want to know is how much milliliters is going to take to make 125 milligrams of from our oral suspension. That's where we start. And then dimensional analysis wise, what we have and then what we need. What is a bridge? The conversion factor. We want to get to milliliters. So our conversion factor is 250 milligrams per 5 ml. What we want is to end up with ml. So we just put milliliters on top. 5 ml over 250 milligrams. So why do we do that? It's to cancel out the milligrams and to end up with ml. You put what you want to end up with on top. So calculation-wise, 125 times 5 divided by 250 is 2.5 ml. Now, what's a way to save 30 seconds of writing for this question? It takes 5 ml to have 250 milligrams of ciprofloxacin. They're asking for 125 milligrams. 125 milligrams is half of 250, which then logically you would think you would need half of the solution, half of the total solution, right? So if you're at 250 and you want 125, 125 is half of 250. So then half of 5 would be 2.5. But for the exam, you had to write it out. So just for your own experience, right? For your own knowledge. Let's keep that actually. Okay, and then C, how many milliliters of ciprofloxacin oral suspension containing 250 milligrams per 5 ml should be dispensed? So that question is asking how much should be dispensed for the whole regimen, the total 40 doses that we calculated earlier, right? So it's 2.5 ml per dose, and this person is taking it 4 times a day. And so we already have that solved out, right? 4 times a day times 10 days. If you didn't have that solved out, you just have to understand that we have our original quantity right here, multiply by 4 to have per day. So 2.5 times 4 is what? 10. 10 times 10 is 100 ml, right? Okay, but let's write it out just to be safe. Make sure I'm not wrong either. 2.5 ml, and that's per dose, by the way. If you just think of it, right? That's how much we're taking per dose. Times 40 doses. Hundred ml. How about that? Just number-wise, it's cool to calculate it that way, but in a real life situation in a pharmacy, it might be easier to go step by step, go with the daily dose, and then go by how the total dose per day supply wise, right? See how I did 2.5 times 4, that's 10, 10 times 10 days, 100 ml. Cool. So that is end of chapter 7. Gonna move on to our next chapter in the next video. And I'll see you there.